Welcome to Physics with Mr. Brazil. Today we'll be talking about projectile motion for an object rolling off a lab table. This also applies to cliffs. So here we go. A purple marble rolls off a lab table with a height of 85.4 centimeters and a velocity of 0.731 meters per second. From the base of the lab table in the horizontal direction, where does the purple marble land on the floor? So let's start with a sketch. So we're going to have a marble. Let's make it purple. It's going to roll off. It's going to come off this lab table and land someplace on the ground. Okay? There's a couple things we do know. We know that the velocity initial in the x direction is 0.731 meters per second. We also know if we put a coordinate plane and started at 0 at the top of the table, then y final is going to be negative, okay, the height of the table, and it's going to be a 0.854 meters. Okay, we're going to, because gravity is in meters per second squared, that's why I chose meters. Okay, the goal is to find the distance on the floor, on the ground from the base, some x final. So how do we tackle this? Well, looking to the left of your screen, okay, or excuse me, to the right of your screen, we know that the velocity in the x direction is constant. That's not going to change. There is no increase in velocity. It remains the same. But in the y direction, starting Vy, oops, let's back that up a little bit. Vy initial, well, that's 0. But as soon as it starts falling, it starts increasing and increasing and increasing. Excuse me, increasing. There is a tangent velocity that goes along as it increases, okay? Well, here's the deal. All three components share the same falling time, okay? All three vectors, as it goes horizontally and it goes vertically down, and the tangent vector, they will all fall at the same time at any point in the parabolic trajectory. So let's set up our y direction. That was in blue, let's keep it blue. So y final equals y initial plus vy initial plus 1/2 gt fall squared. Well, the initial velocity is 0, and since we start a coordinate plane at the lab table, y initial is also 0. So y final equals 1/2 gt fall squared. Well, if we can find the time, because since all three vectors share the same time, we could solve for the distance horizontally. So t fall is going to equal 2 y final, okay, divided by g square root. Let's bring that on down. So 2 times negative 0.854 meters divided by negative 9.80 meters per second squared. And this is going to be square rooted. Okay, I've done this already on the calculator, and it's going to equal 0.417 seconds. Okay, so in the y direction, the object is falling and it's going to hit the ground in 0.417 seconds, but so in the x direction also, it will hit at that time. So we can now use our kinematic equation again for the x direction. X final equals x initial plus Vx initial t plus 1/2 ax t, and I'm going to call these fall, sorry, fall squared, fall. Okay, and wait a minute, the velocity in the x direction, the component, is going to equal to the final and the initial. Yes. So Vx initial is equal to Vx final because it's constant, just as I wrote earlier. It doesn't change. So therefore, there is no acceleration. That's 0. And starting at the base, well, that's 0 also. So our change in the x direction is going to be Vx initial times t fall. And since the velocity hasn't changed, we put 0.731 meters per second times the time, 0.417 seconds. And that's going to equal 0.305 meters, or 30.5 centimeters from the base. So now you can find how far an object will fall. Give it a shot. Okay? Use this video again if you have to go slow it down. Enjoy physics. Until next time. Bye.